This is the start of part one. The first part of this was not really part one. It was just an inspection of the Hallicrafters S-210. What I'm doing now is feeding in 150 volts on the electrolytic, which is right here. May or may not be able to see that from the angle I'm working. And I got it being fed with the ICO 950. The eye is completely open, and it opened relatively quickly. That doesn't mean the electrolytic is good. It could be open. So I'm going to leave this on for about 10 minutes. I already have it on for about 5 now. And what it's doing is it's feeding in from the input filter and then through this fusible resistor, which is good right here. I'm getting 144 volts out of this end. The last time I measured it. It's a little awkward for me to get in there now, but I can do that. This is the common negative. It's not chassis, it's the common negative. It's a 4-section cap. The blue, green, and red, the blue is 25 volts, 25 microfarads. So we don't even worry about checking that one because that's probably a cathode bypass. But the other ones, the other 3 sections are 150 volts. They're 260 microfarads and I believe a 40. So right now I'm powering up the 260s. There's a 60 microfarad, then there's a resistor, and then the other 60 microfarad goes here. Let's see what we got here on our input filter here. I got 146.3 and 146.4. Okay, the radio's off, of course. It's just being fed, yeah. 146.5. So I had the ICO 950 set for 150, but I didn't recheck it, so it could have dropped a little bit. Actually, we could check that now, simply by putting our lead on here and see what we get. $149, 150. Okay, so if we hold it on here, it helps if I put the negative lead on. Okay, she's climbing. 143, 144, 145, 146. Okay, so all right. What I'm going to do now is to go to the other section and I don't know if I'm in camera or not. Let's see. Alright, the green one is a 60 microfarad, I believe. Let's stop guessing and let's look at it. Red is 60, green is 60, yellow is 40, all at 150. Okay, so the yellow has got to be traced out. Now, some of you fellows out there mentioned about this visor thing here in order to see better. Yes, it is, but I have to get very, very, very close, and I usually bang into the work here. And I have to use this piece here too. I don't have my reading glasses on, but in order to use this piece, I got to get my face right on top of it, and it still isn't in focus. So, what I got to do is to find my reading glasses, which I conveniently lost. Isn't that something? I lost them. Where the heck did I put them? Oh, I got them on. Well, that's the best I can do. I still can't find that yellow wire. It looks like it goes on the earphone jack, and it can't. Okay, that's not the same yellow wire. All right, I didn't think so. All right, I gotta get my portable microscope. I could get the microscope camera, but then I gotta drag out the laptop, which I don't have room on the bench for. All right, let's see. This won't focus in without getting it right on top of it. And I literally got to take my head and put it right inside the works here. It looks like that wire goes on one of the pins of this tube here, but it's so crowded in here. I can't get in there. This thing don't get in close enough. It's out of focus unless I'm right on top of it. It's a microscope. But it's not doing me any good at this range. This does a little better at this angle, but it's still... Boy, it's a good thing you're not paying me by the hour. I have to have this right up against the chassis in order to get into focus. Alright, that's definitely on that pin, but I just had to make very sure before applying 150 volts on it. Okay, so it goes to this resistor here. Keep my finger on that resistor, because that goes to the pin also. Alright, so we don't want to lose my place here. Whew. I spend more time trying to find something by looking than I actually do troubleshooting. Get this wire out of the way of that resistor. So I can get my 150 volt clip lead on there, and what I'm going to do is use one of my small leads here, thin ones. Clamp that on there. Okay, and put my voltmeter. I don't even know if I'm still recording. Am I? It's a good question of the day, or the night, I should say. Yep, I'm still recording. Okay, so we're going to get Common negative connected up, which is it's upside down now, so I gotta trace it back again. I think that's a common negative. Yeah, I think so. Yeah, it's a common negative. It's a common negative. Alright, I can put another negative lead on that. That way I can get my meter on there. So we'll get a black lead. And we'll clip it on that resistor, which goes to the common negative also. Alright, now we'll put our voltmeter on the negative. Put that over there. And put our positive on here. And now we're going to feed the B plus in. Helps if I turn my meter on, huh? Did you think it would? Alright, oh, she's climbing. She's climbing. We have 150 volts coming in. On the yellow lead of the 150 volt section of that electrolytic. So the first two sections, which were 60s, both held up and did not break down, had an eye completely open. Let's see what it is here. Eye is completely open on the ICO 950, and the voltage is still climbing. So these electrolytics here were designed for 150 volts. With our line voltage here, I never will have to worry about that because we have an average of 115 to 117, very, very rarely 120. But I don't know about Bob, so I probably will change the electrolytics. I just want to run this now with voltage on them, and they don't break down. I could probably fire this up. I tested off camera. I tested the diode that I showed in inspection video that I just uploaded. The diode is good. There's two fusible resistors, a 220 ohm 5 watt and a 33 ohm 5 watt, which are right here. They both test good, so there's no shorts that caused them to blow out. The thermistor tests good. I think it's like 800 and something ohms right now. Cold. I don't know what it is hot. We are on 145.5 volts right now. We'll take you off here and we'll bring you slowly so you don't get seasick here. There's the ICO holding a wide open eye. Take a look at the meter, 85 volts on the 200 volt scale. When the radio is turned off, the radio is not plugged in to the variac yet, or the isolation transformer. That shows you these capacitors are holding a charge. That's a very good indication of a good capacitor. I may not have to change the filters on this at all. What we're going to do now, folks, is we're going to plug in the radio. Where the heck is the plug here? All right, let's find the plug, you old goat. Of cord's got to be all knotted up here. See if I can reach it. Okay, she's in. All right. Let's put it on. Turn the volume up all the way. 41 volts. No current draw yet. 52 volts, no current. So something could be open. It could be an open tube, burnt out tube. The voltage is still dropping, so we're not getting any B+. It uses a solid state rectifier, not a rectifier tube. And we'll put this up to 70 volts. No current draw. None whatsoever. But we are getting 95 volts now, so it is going up. So let me crank the variac up. It's on 70 volts right now. 80 volts. No current draw. We'll push it up. $90 volts. This is the input filter you're looking at, without any tubes lighting. Tubes are not lit. If the tubes are lit, we'd be drawing current. We're not drawing. We're drawing 0.01 amperes. Now let's go to 100 volts. Exactly 100. 135, 136 volts on the input filter cap. Now you remember I did all this on the ICO 950. That's what I usually do on the radios, is run the capacitors up, and if it's going to break down, I'd rather have it break down with a current limiting source such as the ICO 950 or even my Sprague Telemic. But this is more convenient right at the moment to use. So we got a solid 100 volts coming in, and very little current draw, 0.01 amperes. It's not even moving the analog amp meter. All right, so we'll put it right up to, well, put it up to 120 volts. Still no current draw. 162, we got to drop that down. Drop it down to 116 volts. So if you got 120 volts on the line voltage, that's going to be too high for these electrolytics. At the time this radio was made, the average line voltage is probably about 117, which is what we get here. You also have to remember that this voltage that I showed you and you're looking at here is with the radio tubes not lit. In other words, there is no current being drawn off the B+. The readings you're getting is just from the diode charging up the electrolytics, and that's a higher reading than you would normally get. If the radio was working, you'd probably be 10 to 15 volts lower, and that should be just about where we should be. We should be under 150 volts when this radio's working. So I think the next step is to test the tubes. So we shut off. The isolation and the variac, and we'll commence to test the tubes. This concludes part 1